through how to process data on Excel. It's important that you have these headings that have the unit and the uncertainty of the measurement, right? And that goes here as well. You can, if you want to create like a big box like this instead of little ones, you can go to, select them all. So select a bunch of boxes, go to Format Cells, go to Alignment, and then you can click Merge Cells, and it's going to merge any cells that you select, and that's what makes this big box here. Okay, so what we need to do next is we need to decide, okay, we took 5 measurements for a diameter. Which one should I actually use for the diameter? Well, we should use the mean, right? So in our heading, we're going to say D mean, and this is going to be in grams. And you should be able to select this and make it like a subscript so it looks a little bit better. So if you click Format and then Subscript, depending on what computer you're on, my computer seems to not like that. So another option is just make the mean part real small, and then it looks a little bit better. Right, so for the mean, we're going to take the average of all of these. The easiest way to do that is just start typing the word average, right? And you're going to select all your data points, close the parentheses, press enter, and then you can just drag all of these down. Now the next thing we want is we want to know what the uncertainty for this is going to be. And so what we need to do is insert the uncertainty symbol, which is that delta symbol. So go to Insert Symbols. You definitely don't want emojis. Let me see if I can search for delta. Oh, that's really close. There it is, delta. D mean. And again, I'm just going to make this mean really small so it looks better. If you have a decent computer, it'll actually do that subscript for you. And this is also in grams, right? And so the way we figure this out is basically the uncertainty, the absolute uncertainty, we're going to use the range of these. So the easiest way to find the range is to find the min and max values, and you can let Excel do this for you, right? You just start typing equals max, right? Click on that function, and then select the values you want to find the max of. Drag this down, it'll find the max of all those different data points. For the min, you do the same thing. You start typing min, select the data points you want to find the minimum of, press enter, and then for this you're going to do, make sure you do parentheses, max minus min divided by 2, right? And then you can just drag this one down as well, and that's your absolute uncertainty for the diameter. Now, oops, I didn't drag those. There you go. I want you to notice something. Notice how this is giving me so many significant figures, and I had already fixed all these ones over here. So let me just show you before. Before I did this, it looked like this. Well, something like that. Actually, it was just this one that looked like this. And you may not notice it, but it is important that this shows 2 significant figures, right? It's important that the uncertainty, whatever digit the uncertainty is, matches the last digit of your number, right? Because that's the uncertain digit. So on this one, I had to press this so it show the 0.0, so I know that this is to 2 significant figures, and then this is the uncertainty in that last one. And I did that with all of these as well, right? Making sure these are all 3 significant figures. And I should also make sure my mean is in 3 significant figures, right? So if you need to adjust this, you don't want it like 4, you want it in 3 because all these ones were 3. The same thing goes here, right? Like for this, I guess the D max, D min don't really matter, but for this, we may or may not be able to give more than 1 significant figure. So let's figure this out. Let's figure out. I'm going to go and copy this. Let's figure out the fractional uncertainty. Right, fractional uncertainty is the absolute uncertainty divided by the actual, our best guess. And you don't need to put units on this because there are no units to this. That's, the units cancel each other out. So this is fractional uncertainty. So we're going to take the absolute uncertainty and divide it by the best guess that we had. And again, we might want to show a few more significant figures on this one. Let's just show that many. If you remember the general rule, that is if your fractional uncertainty is less than 2%, then you can use 2 significant figures in your absolute uncertainty. So the only ones that are less than 2% are this 3rd and 4th one. So for the rest of these, I'm going to go to make them 1 significant figure. right? And again, the only reason these can be 2 is because their fractional uncertainty is less than 2%. You see that? Okay. So the first thing you're going to do is you're going to go and graph these. So you're going to select, you're going to graph mass versus mean. So you're going to graph these. You hold those down and you then go to insert and you click on the chart and you just insert a scatter plot. You're not going to want that there, so you're going to drag it down a little bit here. Make sure you put a chart title. I'll let you decide what that chart title is. It's also really important that you put axis titles, and in your axis titles there should be the unit, right? And you also need a vertical axis title, and that should also have a unit. This one was diameter, and it's in centimeters. All right, and so you know, who knows what kind of shape of graph you're going to get first. I want you to do 2 types of graph because part of what you're learning here is also linearizing. So here's one, and what we're going to do is we're going to add another chart element. We're going to add a trend line, and if you don't see it there, you're going to add more trend line options. You know, this one, let's pretend it wasn't linear at first because it's not supposed to be linear. Just my data, I was just kind of making up my data, so it's not really great. Let's pretend it was like actually a polynomial of order 3, right? It was like a cubic function, which it should be if you read the instructions, right? So that would mean that would look like this, and I want to display the equation on the chart, right? So that looks like that. I also want some uncertainty bars, right? Even on this graph, I want uncertainty bars. So we're going to go back to add chart element, error bars, more error bar options. Right now we're on the vertical error bar, right? Vertical was our mean. So what we want to use for our absolute uncertainty are these numbers. So we go down to custom, specify value, and we're going to select our values for absolute. Over here, it's important you delete that 1, and then you also select those values, right? And then it's going to show you those vertical error bars on there as such. All right, and then we need to take care of the horizontal error bars. So we're going to, I think you can actually just click on them. Let's see. Yeah, look, see, you double click on it and you get horizontal error bars, or you go over to add chart element like I did before. In this case, it's just a fixed value, right? For every one, it's 0.1, right? So for all of these, it's going to be 0.1. All right, and then you can see now it looks kind of like this, and it would look better if it was a little bit bigger. Let me see if I can make it bigger. All right, there, and you know, obviously, zoom out a little bit, and you can see the error bars, and the horizontal ones don't really show up that great on here. We could change our axis a little bit if we wanted to. Let's look at this and just see if it helps to change it. Like, we don't need to go all the way to 25. Maybe if we go to 23. No, we don't want to. This is 0. Yeah, I mean, that's probably as good as it's going to get, right? I mean, so maybe not even do that. All right, so that's that one. What we really want is we want a straight line, right? Because if we can linearize it, we can find a slope, and then that slope is going to help us understand some stuff, and that's what is in this activity toward, you know, in the middle. It shows you what you should be getting. So in order to linearize it, we know that volume is a cubic function. So, so you want to save this because this is part of it, right? I'm just going to put it off to the side right now. This is, just keep it down there. Zoom in again. Okay, so we know that volume is a cubic function, so we're gonna find the cube of the diameter, and you could do this a different way, like the radius. You just have to make sure you're careful about how you go about it. So over here, what we're gonna do is we're gonna do we're gonna do the mean cubed, right? So we're gonna be cubing the mean, which means I'm going to write it like that for now. There's a better way to do that, but it doesn't seem to be working. Let me see if I can get it to work. You should be able to select it, go to Format, and click on Superscript. but it doesn't work for me. So I'm just going to do it like this for now. And then this is obviously going to give us cubic grams, right? And this is pretty easy. You can just do equals your mean diameter to the third power, and it gives you this. If it gives you a bunch of hashtags, you know, the pound sign, you can, it's probably just you need to press. Watch, I'll show you if you're too far this way. Sometimes it'll give you a bunch of hashtags, but it's obviously not doing that right now. So, so there's our uncertainty, or there's our cubic, the cube of our diameter. We also want to know what the uncertainty of that is. And so if you remember for, no, let's take this one. We want to know what's the uncertainty, the absolute uncertainty of the cube in grams cubed. The way we calculate this is we first need to use the relative uncertainty, right? And we're going to multiply the relative uncertainty by whatever power it's being raised to, which is 3. And then what we really want to know is the absolute uncertainty. So if I do K3 times 3, that's going to be the relative uncertainty, right? Because it's the relative uncertainty of the diameter times 3. So to get the absolute uncertainty, I need to multiply by the actual cube of the diameter, and that'll give me the absolute uncertainty of the cube of the diameter, and drag those down, and you get this. And so now what we can do is we can graph mass versus the diameter cubed. Oops. Mass versus diameter cubed on a scatter plot. And you can see how it's very nice and linear now. And so now we can do a trend line again. I'm going to go to more options because I want to make sure I can display my equation. I want it to be linear. Sometimes it's nice to see a little bit before, a little bit back. So I'm going to go ahead and put 1 forward and 1 backwards, and it's just going to show a little bit beyond. Or it should anyway. Let's see, once I close. Yeah, okay, so went a little bit forward, a little bit back. We also need our uncertainty bars here, so we're going to, again, go to Add Chart Element, Error Bars, More Error Bar Options. Looks like we're starting with a vertical again, so we're going to go to Custom, Specify Value. In this case, we're using this absolute uncertainty over here, right? So we're using this, and down here we're using this, right? So now you can see you have your vertical. So now we need to go to the horizontal, and again you can just double click on the horizontal error bar and it'll show up. And for this one, again, the horizontal was just 0.1. Alright, so you can see there is kind of a problem with this, is that we missed all our error bars up here, right? The line of best fit should always try to go through all the error bars, but so that is something in your analysis, if you do an analysis, you'd want to talk about how you know, it's not great because you have you're missing this one up here. It hits all the other ones, which is good. Okay, so now we're gonna do the line of worst fit, right? Right now we have the line of best fit. We're gonna put in the line of worst fit, and you know what I might do on this is, like, if I notice this one, I might like remeasure this one if possible, just because, you know, it seems like that is not lining up with the trend that it should. But anyway, and don't forget your axis titles on this as well. I'm just trying to go through this kind of quick for you. So the next thing would be line of best fit, line of worst fit. If you remember the line, we want the line with the steepest slope and least slope. So line with the steepest slope is going to start at the bottom right of this error box down here, and it's going to go to the top left of this error box up here, right? So what that means is we're going to go ahead and do some more information over here. I'll just do it down here. You have X, you have Y. We'll start with go to merge these. We'll start with the max. So the bottom left, the x-coordinate is going to be right by the absolute uncertainty and then down by the absolute uncertainty, right? So this x-coordinate is going to basically be that this x-coordinate here, that's the x-coordinate, but then we're going to go right, so we're going to add the uncertainty in this measurement, which is 0.1. So we're going to do that plus 0.1. Right? Now the y-coordinate here is that y-coordinate minus whatever uncertainty is associated with it, right? So this is equal to, the y-coordinate here was determined by the cube mean, and we're going to subtract the uncertainty that went along with it, right? And then up here for this one, it's going to be top left, right? So for that, it's going to be the last x-coordinate, which is this one. Which, since we're going left, we're going to subtract the uncertainty, which for the mass was 0.1. And then for this other one, it's going to be bottom right. Or sorry, we're still doing top left. Top left is then you take the y-coordinate, which again is this, but since we're going up, we're going to add this uncertainty, which gives us that, right? So then now what we're going to do is we're going to add this data to the chart. So you double click on this, you say select data, you go to the plus sign. Let's go ahead and name it. This is going to be the max slope. The x values we're going to choose are these. The y values we're going to choose are these. And then we can press OK. And obviously something went wrong because it's something way up there. So let me try that again. That's right, that's right. Oh, there's no way. Oh, this one's wrong, right? Because I was supposed to select this number. I selected C. Oh, I selected the wrong thing, right? So let's do this one again, right? This is the top right, so it should be the last coordinate point and then subtract the uncertainty. So the last coordinate point is 19, subtract 0.1, right? And so now you can see the 2 points are there and there. And what we're going to do is we're just going to add, so click the chart, go to chart design, add chart element, trend line. It should give you an option. What do you want to create it for? I want to create it for the max slope. It gives you that line, and you can then tell it to display this equation, and it will put that equation there for you. Now in this case, because this point is so off here, you're not going to be able to go to the bottom right of this one. That's what you would normally do, right? Like the trend line should ideally go through the middle, and then the line with the least slope should go through the bottom right. That's not going to be possible here. So we're going to go ahead and create another line that goes through there a little bit. That's close, but it's not going to be as precise of an art as the last one was. So I'm going to merge these, and we're going to go ahead and do minimum, right? So we're going to, the same idea, right? Minimum, we would start here on this chart and we'd use the top left. So that means whatever x value I have, I'm going to subtract something, right? So I'm going to subtract the uncertainty. So from this one, I subtract the uncertainty. And then for the y coordinate there, you're going to be on the top left, which means you're adding the uncertainty to the first point. So you're taking this and you're adding this uncertainty. Now for the top one, if it were ideal, we'd use top the bottom right of this box, which would be you take your x coordinate, which is this, and you add your uncertainty, and your y coordinate would be you take it and you subtract your uncertainty. So you take this and you subtract that. Now you can see this is not going to work. I'll go ahead and do it for you just so you can see it's not going to work, and then we'll mess around with it, right? So select data again, add. This one's going to be called minimum slope. The x values are just going to be these two. The y values are just going to be these two. Press OK. And again, I messed something. Somehow I did this one wrong again, right? So it's equals u minus 0.1. There it is. It's those gray dots, right? And so then again, we're going to go to chart design, add chart elements, trend line, more trend line options. This time we're doing min slope, and we're doing linear, and so we want the equation on the chart, right? It lets you choose like a color, maybe something better than gray, right? Maybe let's do red for the minimum. Maybe that'd be better for this one. And so you can see it's not actually the equation with the minimum slope, right? And the line of best fit is calculated mathematically. So what we need to do is we actually need to, manipulate this so that it still goes through all of these as much as possible, but is that, maybe lower than the best line. So maybe what we should do is lower the y min here, right? So you can actually just, let's just take this and let's subtract, let's see what happens if we subtract 1. That got us a little bit closer. Let's subtract 2. And you want to check, is it still going through all these? Maybe try to get it to go through the bottom of all of them. So if you can see down here, you want it to go through the bottom of that one. So we just, this is kind of a imprecise art at this point, but we just want to make sure it's going to do what we want it to do. So we can do a little bit more. It's probably as far as we can go, right? Because you see how it's just barely passing through this one. We can't really go any lower than that, otherwise it won't pass through this one. And we could of course just change this to add 1 to it or something so it goes out there a little bit more. Actually that doesn't work because now it's too far off, so let's not do that. Okay, so there we are, and you have your 3 equations and your slopes, right? And so if you wanted to find the delta, I'm just going to go ahead and copy this, delta of the slope or gradient, which is, think about what the slope's going to be. It's going to be d cubed over g, right? Rise over run, d cubed over g. So the units here are d cubed over g. You would just take the biggest slope, so 2.0389, minus the smallest slope, 1.6324, and divide by 2. And we need some parentheses. And so that's your uncertainty in your slope. Again, you need to adjust how many significant figures you want, right? Probably 0.2. You should also, if you can, adjust the significant figures here because it's obviously not accurate to that. It's actually just going to be 1.8. And then all of these ones as well, you can adjust. And so now you have your slope. You could also find uncertainty in the y-intercept if you wanted to, and so on and so forth. Hopefully your data is a little bit nicer than this one was. That's what happens when you just make up data. It doesn't really work out that great. All right, so I hope this helps you figure out what to do.